So we're back to, we did one earlier in the notes last week about light bulb manufacturer. In this case, the manufacturer produces 35,000 light bulbs. From past experience, the mean life is 900 hours and the standard deviation is 50. Determine each of the following values. It says round answers to the nearest 100. We're just going to look and use this. We're not going to use our calculator. We're going to use the standard normal distribution there. Okay, so you can do that if, depending on what questions you're asked. If all the questions involve 1, 2, 3 standard deviations above, or 1, 2, 3 standard deviations below, you can just use that. Okay, so it says the percentage of bulbs that will last between 800 and 950 hours. So remember that the mean is 900. Okay, so 800 is really the mean minus 2 standard deviations. Right? So that is here, a z-score of -2. So we're going to look from -2 to 950, which is 1 standard deviation. If you want to actually label the values, so the mean is 900, this would be 850, this would be 800, this would be 750, this would be 950, 1,000, 1,050. That might make it faster. Okay, so we're going between 800 and 950. So we're going to add up 13.59, 34.13, 34.13. Okay, and it says percentage. So we'll use the percent form. Okay. So that's going to be, I'm just going to clear that. And so 13.59 plus 2 times 34.13. So 81.85%. Then the percentage of bulbs that will last between 825 and 875. So now those values are between. So they're not an exact integer value of a z-score or standard deviation. So now let's use our calculator for this one. Okay, so we want to we're finding the probability, so that's second distribution, normal CDF. Okay, we're going from 825 to 875. Don't use zeros and ones, it'll give you an error because you're using data values and then z-scores. You've got to be consistent. So now our mean is 900. And our standard deviation was 50. Okay. Enter on that. And then, of course, round to the nearest 100th of a percent. So if you multiply by 100, then it's 24.17%. So we take, this is norm, let's see. A little bit better smart board. Say 24.17. So then the number of light bulbs that will last between that, you have the answer in your calculator. You know how many were produced. So you take that and multiply by take that and multiply by 35,000. So just go, so that was by 100. So I need to go back to, you can just go back to the decimal form, not a percent, multiply by 35,000. Really important that you don't use the rounded version, especially with a big number like 35,000. You won't have the exact answer. Okay, so please do not use the rounded version. So go back, multiply by 35,000. Then you can round to the nearest whole light bulb. So 8,461. We'll just use regular rounding rules. Okay, but it's a light bulb and a part of a light bulb, so we'll round to the nearest whole number. Same thing with the next one, 920 isn't one of the values on your horizontal axis that's labeled, so it's not a integer value of a z-score. So we want to use our calculator. Probability that it will, bulb selected at random will last less than 920 hours. So that's the area under the graph where this is 920. So you want to find all of this area, okay? And so, again, you're given the data value. You're trying to find the probability or the area underneath the curve, so you're using normal CDF. So second, bars, number 2, normal CDF. Now we're going from the smallest negative value, so -1 e to the 99 to, what did we just say? It was 920. The mean and the standard deviation are still in there from the last question. So then just go to paste. If you have an older version of the calculator, that's what you're entering, right? Lowest, highest, mean, standard deviation for the data. Enter on that. And 0.66. That was norm. CDF. Okay, the number of hours that at least 84.13% of the bulbs are expected to last. So that would be the first 84.13%. Okay, so the number of hours, right? This is the number of hours. So to redo this normal distribution, that's more than 50, so this is 0.8431. And so we want to know how many hours that is. Again, I don't need to know the z-score on that. We just did a whole bunch of questions in the last part where we found the z-score with it given the area. We know the mean and standard deviation for this data. So let's get it right away. So that's going to be second distribution, inverse norm. Okay, the area 0.8413. Mean is 900. Standard deviation is 50. And we're going from the left. So it's going to be the same whether you have an older calculator or a newer one. and that rounds to 950. So we could have probably figured that out. 950 is the mean plus a standard deviation. So if we had added up 50 here plus 34.13, then we would have got it without our calculator. Okay, so we could have done it that way. Okay, but you may not have realized that. So this is 950 hours. Oh, crazy. Okay, the number of hours that at least 32% of bulbs are expected to last. Okay, so again, 32%, so that is the bottom 32%. Okay, now, well, let's just think about this for a sec. The number of hours that at least 32% of the bulbs are expected to last. So actually, when you think about this, do our graph here. We could, so 32% from the beginning, then all of these would be lasting 32% as well, right? So those number of hours. So I think we need that 32% at the end here. So we need the right-hand value. Okay, because that would be at least. Okay. So, in this case, if you don't have a newer version of the calculator, then this area here would be what, 68%. If you have the newer version, then second, distribution, inverse norm, 0.32, and then we're going to choose the right. All right, so the study shows that the mean duration of a certain strain of the flu virus was 12 days with a standard deviation of 3. If you caught this type of flu, what is the probability to the nearest 100 that it would last between 13 and 15 days? So if you were to graph this, mean is 12. And then often I put the standard deviation just underneath is 3. And so between 13 and 15 days, that would be here to say here. We're trying to find that area. Okay. So our lower boundary is 13, our upper boundary is 15. In our calculator, we're trying to find the probability. So second bar's normal CDF. And then between 13 and 15 days, mean of 12, standard deviation of 3. Okay, so that's what it's going to look like for everyone. And so 0.21. 21% chance, right? But this then is 0.21. Okay. So I didn't write it out. You're gonna have to write it out in a written response, but my Epson Warren is struggling, so it's a little bit easier. Longer than 17 days, so again, it's 12. Standard deviation is 3. 17 days would be maybe about there. And you're trying to find that area, so you're going from 17 to positive infinity, or in your calculator, 1 times 10 to the 99. So 17, and then 1 e to the 90. No, this is a Monday, that's for sure. Delete. Oh, now it's 2 of them. Delete. Delete. Okay. Now we can go. 0.05. Next one, from extensive testing, an appliance distribution company knows that the average life of toasty toasters is 4.2 years, and the standard deviation is 0.65 years. The company does not want to replace under warranty more than 8% of the toasters that are sold. What guarantee to the nearest necessary year should the company offer? So basically, how many years should they say their guarantee is? Oftentimes, it's a 1-year guarantee. So if it breaks down in 1 year, you can send it back and get a replacement, or they'll fix it. You have to read fine print. It's not always a replacement, but in any case, that's what a warranty is. Or maybe it's a 6 months, or maybe if it's a car, it's, you can buy it. You have to buy the insurance basically for that warranty, like for 3 years or 5 years or whatever it is, but they don't want to replace it under warranty more than 8%. So basically, here knows that the average life is 4.2, so that's your mean. So 4.2, and your standard deviation is 0.65. Okay. So if they gave a guarantee of 4.2 years, they would have to replace 50% of their toasters, right? Because that is the mean. So they only want to replace 8%. So that means the first 8%, right? So here, this part here, 8%, 0.08. It's actually going to be further to the right. Let's do it here. Okay, so 0.08. So we want to know what year that is. Okay, to the nearest 10. Oh, I just wrote it on the wrong one. It flipped. Okay, sorry. 4.2, standard deviation of 0.65. That's what we want. That's 0.08. Okay, so we're given the percent, so we're using inverse norm. So second distribution, inverse norm number 3. Area is 0.08. Mean is 4.2. standard deviation is 0.65, and this is to the left. Okay, so 3.3 years. So what guarantee should to the nearest necessary year? So the word necessary in there means it might not be your normal rounding rules, but in this case, if we rounded it to 3 years, normal rounding rules, that makes sense. If you, for example, rounded up to 4 years, then they would be replacing more than 8% because it's to the right? So normal rounding rules work in this case. So the warranty should be a 3-year warranty. Which, gotta tell you, is not really gonna happen, usually for a toaster, but whatever. Okay, I gotta erase this, because I put it down there and put it on the wrong one. Okay, so it was found that 37.7% of the shrimp harvested at shrimp harvest farms had a mass of less than 135 grams. If the mean was 145, determine the standard deviation. Okay, so this one, we know the percent, 37, right? So say something like this. So 0.377. We want to find that value. We know the mean is 146, but remember what you have to put in your calculator, right? In your inverse norm, you have to put the area or the probability, the mean, the standard deviation. We don't know the standard deviation, okay? So this is the case where we need to figure out the Z-score of this first, and then use that formula to calculate the data value. Okay, so here, this is your, these are your grams, right? Now in your Z-scores, that's 0, and your standard deviation is 1. Okay, so we're going to find the Z-score first, Z1, just Z. Okay, so Z will equal inverse norm. Okay, the area is 0.377. Mean of 0, standard deviation of 1, because we are getting the Z-score, not the data value. Okay, so inverse norm. So 0.377. Mean of 0, standard deviation of 1, because we're doing Z-scores, and we're going to the left. Okay, so Z-score of negative 0.313369. I'm not going to round it. Okay, so I'm going to show a few decimal places. I'll keep it in my calculator. So I'll show 4 decimal places. Negative 0.3134. Okay, now to get that data value, call it X. So remember the formula, Z equals X minus the mean over the standard deviation. And the mean can be X with a bar or mu. So in this case, we have negative 0.3134 equals, X is what we want to find. Our mean is 146, and sorry. What did I just do here? I found that, yeah, 135. Okay, so here. I know my X is 135. So we know the Z-score from that, so I've got my X and I'm trying to find my standard deviation. Okay, so when you solve that, these will really interchange, right? So if you multiply through by sigma, then you can divide by z. So if you want to do that right away and say, okay, my standard deviation is going to equal x minus the mean over z. You can do that right away. Or you can put the numbers in and then do it. What's 135 minus 46? So that's going to be negative 11 over negative 0.3134. Okay, and so in your calculator, go negative 11 divided by that answer, right? So second negative is the answer. You can go up and select it. Okay, so that's 35. So our standard deviation is 35. What did it say to round to? Nearest 10, so 35.1. So there are times where you might have to, and it's always the same units as standard deviation is in the same units, but you might have to, in an application question where they give you data values, the mean, they might not give you the standard deviation, you need to convert or calculate the z-score and then use that formula to get it back to a data value, okay? But if they give you the mean and the standard deviation of your data, you don't need to convert it to a z-score and then use the formula, only if you're missing one of those values, okay? So just be aware of that. And I think that's, oh, one more, right. Okay, so turn over to the last side. Okay, so the marks of a large number of students have been represented on a standard normal distribution curve. The values given represent the number of students in each area. Determine the value of Z1 to the nearest 100. Okay, so remember what you're entering when you're entering to find Z, that's inverse norm. You need the probability or the area underneath. It will give you an error if you put 452 or 1,250, right? It's always a value less than 1 because you're entering a probability. So in this case, you can tell me the total number of students that were in this data selection. 2,500, exactly. Because this is 50%, and so it's double that, right? So depending on what calculator you have, if you have a newer version, then you can just add these together, divide by 2,500 to get that percent. If you have an older version, you're going to basically subtract that from 2,500 to get this. Okay, so it just is one extra step. But this area here as a probability will be, what's that, 1702 over 2,500. That looks like a 6. I'll fix that up. Okay, you can even show it as a fraction in your calculator. So now, when we're finding this, we're doing second, distribution, inverse norm. Okay, so you can go 1702 divided by 2,500. Then you don't have to worry about any decimal places or anything. We're finding z-score, so 0, 1. But for newer versions of the calculator, we're doing this and we're choosing right. And then based on that, and you get negative 0.47. Okay, so if you have an older version of the calculator, then you would go, this area here would be 2,500 minus 1,702, which is 798 over 2,500. Okay, and you would use that to get the same z-score. Okay, any questions on those? Okay, that's it. So lots of practice on these. Sorry about the Epsom board today, but lots of practice in your booklets. Remember, your assignment on Wednesday is on everything on the back page of that green. So 3 lessons worth. Okay, so that's it. It's not on anything more than that.